Welcome back to Digital class, and this is a discussion for our test 2A 3 states of water of our P5 science. Now, just a quick reminder, once you have done watching this video, you should have also already completed your correction and you are supposed to pass this test paper for your parents or guardians to sign. So again, take note that the parents or guardians are supposed to sign on the right top of the test paper. Okay? So now let's start and discuss about our test 2A 3 states of water. So again, the first thing that you should know before starting doing this test is again the RAISE method that I've mentioned many times. Again, RAISE. R stands for read. You are supposed to read all the questions carefully. A, you are supposed to annotate. Please annotate all the important keywords. Next, you're supposed to identify the topic that the question is actually testing you. S, select. You're supposed to select the best concept to explain the particular question. And E, yes, as you know, explain, or of course, we have eliminate. Eliminate is for multiple choice question. Explain is for your open-ended question. Okay? So now, by knowing this, let's look at our first question. The diagram below shows the changes in the states of a substance. When you see changes in state, automatically you can kind of imagine, oh, this is about water cycle topic, right? And we have solid, liquid, and gas. Now, this is the basic of this whole booklet. So you should know this, okay? But unfortunately, I see some of you get it wrong, okay? So solid became liquid. What is this called? This is called melting. And again, once you know solid become liquid is melting, so obviously you know that 2 and 3 is wrong. Okay? Now let's move on and look at the next one. Liquid become gas. It can be either boiling, it can be either evaporation, right? Okay, so if you look carefully, can you eliminate any? No, boiling, evaporation. Good. Gas become liquid. Gas became liquid. This is something we call as condensation. Okay, condensation. So you can see that obviously option number 4, which mentioned is freezing, is actually wrong, because freezing is the state, is a process of the substance from liquid turn to become gas. Okay, so there will be option number 1. Okay, if you're wrong for the first question, means that you would really need to spend more time in understanding how this processes works. Okay, now let's move on to question number 2. Question number 2 here says that a block of ice, you can see the ice, is placed in a closed box, as shown in the diagram below. During melting, what will happen to both the ice and the temperature of the air in the box? Can you see the word in the box? Okay. So now, the first thing you should understand when it comes to this question is, you can turn to your booklet number 2. Okay, let me just turn to booklet number 2. And you notice that I have already actually mentioned many times, when ice cube is melting, what happened? Can you see the word here? Gains heat. But although it gains heat, but the temperature of the ice and the water from the melted ice, it will still be 0 degrees Celsius. Again, it gains heat, but the temperature of the ice and the water from the melted ice, it will be still 0 degrees Celsius. But teacher, it gained heat, but why is still 0 degrees Celsius? Because it's actually trying to break the particles. As you know, right? Solid, the particles is arranged like very closely. But when it comes to water, I mean liquid in this case, okay, it can be a little bit like further away. Okay, so the heat is gained to break down the particles. Okay, so ice, does it gain heat? Yes, during melting it gains heat, so it's not losing heat. So number 2 is wrong, number 4 is wrong. And with that, because you are gaining heat, so the temperature of the air, will it be cooler or hotter? Now again, ice is gaining the heat, so when the heat is taken away, the temperature will become cooler. And when it's cooler, the temperature of the air will decreases. Okay, so the answer is option number 1. Okay, so it's not remain the same. Okay, but if they ask the ice, yes, it will be remain the same. Okay, but it's asking the temperature of A in the box. Now let's look at question number 3. Question number 3 here says that Emma's left 3 cubes of ice of different sizes on the dining table at the same time. Okay, so you can see ice cube P, Q, and R. Okay, let me just circle the keywords here. 3 cubes of ice, but different size, but at the same time. Okay, which of the following statement about the melting ice is true? Again, you can identify the topic already. It's melting. True, be careful. A. Ice cube P had the lowest temperature. Is that true or false? No, it is false. Why? Again, go back to your booklet number 2. You still remember that, right? The temperature of ice will at 0 degrees Celsius. It doesn't mean that if the ice is bigger, it will be lower temperature. No. Or 0 degree Celsius. B. The time taken to melt the ice cubes was the same. The time taken to melt the ice cube was the same. Do you think is it true? No, right? When it's bigger, right, it needs more heat and it takes more time. So it's false. It's definitely false. C. All the ice cube will have a temperature of more than 0 degrees Celsius. Again, look at your booklet too. It actually explains it should be 0 degrees Celsius until it fully melted. So it's not possible. Okay. So D. Ice cube R require more heat to melt completely. Yes, it require more heat because it's bigger in size. So the answer is option number 2, which is D only. Okay, so I think it's kind of clear for this question. Again, it goes back to your booklet number 2. Again, here, the note here that I actually asked you to put a star there because it's very important. Now let's move on to question number 4. Question number 4, he said that the table below shows the freezing and boiling points of 3 substances E, F, and G. Which of the following statement is correct about the substances if they are placed in the room at 28 degrees Celsius? Now, again, the first thing you should understand is if the temperature is below freezing point, it will become solid. If it's above freezing point, it will become liquid. But if it goes beyond boiling point or at boiling point, then what happened? It will become actually a gas state. So now let's look at here. Substance E, when it's at 28 degrees Celsius, now 19 here, 102 here, 28 will be here, right? Celsius, E will be in a solid state. Is it correct? No. 28 up here is what? Liquid. So 1 is wrong. Number 2, substance G will be in solid state when it's at 28. So 28 is where? It's here, right? Because you can see compared 28 is lesser than 71. And is 28 degrees Celsius a solid now when it's come to G? Yes, that's right. So the answer is option number 2. Okay, so I mean that's clear enough, good enough. When you eliminate, you found the answer. So I mean, by putting like this solid, liquid, gas, actually it helps you to actually identify it easier. Okay, easily. Okay, so let's move on to question number 5. Again, the same thing. The table below shows the melting point and boiling point of substance A, B, and C. So again, when it's below melting point, it is a solid. Okay, when it's in between melting and boiling point, it's actually a liquid. And when it's above boiling point, it's a gas. Now, at which temperature will the 3 substances be in the same state? Now, you see, 32. If 32, it will be here. But in this B, 32 will be here. But 32 in this C, it will be here. Can you see? Means that A and C will be solid, B will be liquid. mean it's not the same state. Can you circle the word same state? So I know A is number one is for sure wrong. So let me just erase that. How about B? B is 60 degrees Celsius. So 60 is in between 42 and 78. It's also in between 28 and 63, and also in between 54 and 90, which is the substance C's melting and boiling point. So I know that 60 is best temperature for me to answer this question. It will be in the same state, which is liquid state. So answer is what? Option number 2. Simple. Let's move on to question number 6. Question number 6 here says the diagram below shows 4 similar beakers RSTU, each filled with 100 ml of water at different temperature. Let me circle the word each filled with 100 ml of water. Means that the amount of water are the same, but it's with different temperature. Each beaker was covered with a small lid. This is covered as some you see, and placed on the table at room temperature of 30 degrees Celsius. So now you know that the water inside is a different temperature, but the room temperature is 30 degrees Celsius. Now, when you look at this water, hot water, cold water, there's a lid, you should actually go back to your booklet notes. You should kind of able to get is actually this one. Can you see this condensation? Do you still remember I mentioned about this part? Condensation in different temperatures of water. Now you see, when the water is in room temperatures, means at 28 degrees Celsius, like normal temperature, there's nothing there. When it's cold, there's water droplets form outside of the cup. When it's hot water inside, there'll be water droplets form on top or the inner side of the lid. Okay, so when you go back to this, somehow you can kind of get the idea, right? Which of the beakers will have the water droplets forming on the outer surface of the beaker? Which means that the water should be cold water. Correct? Cold water. So as you can see, 10, 70 is kind of hot already, right? 20 is cold. So 10 and 20 is cold water. That's why there'll be water droplets forming outside. Okay? So the answer will be what? R and T, which is option number 2. That's good. I think it's good. Let's move on to the next question. Question number 7. Question number 7. The diagram shows a cup of hot coffee placed on the table. And which of the following processes resulted in the formation of the white cloud? Now, you need to understand that this white cloud that formed is actually tiny water droplet. Again, you need to be very careful that this is not water vapor. Now, a lot of you thought that it's water vapor because it's gas, but water vapor cannot be seen. Only water or liquid can be seen. In this case, this is water droplets, but it's very tiny water droplets. It's considered as a liquid. Okay? But, yes, I know this now, but why? What is this? Now, look at here. Okay, turn back to your booklet. When this is actually formed, the white cloud that is formed, what happened here is the warmer water vapor in the air comes into contact with a cooler surrounding. Now, not surface, in this case, cooler surrounding. And this warmer water vapor is from where? From the coffee, from the drink, right? Which is the coffee. The air comes into contact with the cooler surrounding. It loses heat and condenses to form tiny water droplets. So this is what is actually formed. So I mean, from what I'm reading here, you actually can know that this is actually called condensation. Okay? So let's move on to question number 8. 3 identical beakers A, B, C were filled with equal volume of water of different temperature. The beakers were covered with identical lids and placed on a table with a room temperature of 29 degrees Celsius. Now, water droplets will form on cups B and C are shown in the diagram. So you see, A, there's no water droplets formed. B, there's water droplets formed inside. And C, there's water droplets formed outside. And again, let's go back to your booklet notes. Do you still remember this? which is something I just discussed. Room temperature, there's no water droplets. Cold, water droplets form outside. Hot water, water droplets form inside. So you can see that this is actually the hot water. This is actually the cold water. Now, this is a graph, and you say the graph shows the changes in temperature in the water over a period of time. So you can see the temperature of water is at first is very high, then slowly decreases, and it remains and maintain the same. So I mean, you know that A is always room temperature, so not for sure not A. B is hot water. I mean, it works, right? It is exactly what the graph is showing, right? You have hot water, that's why the temperature is very high. But I place on the table for a while, then it slowly go down. I mean, so it's very obvious it's actually C, number 2, beaker B only, which is option number 2. It cannot be cold water, right? Cold water, the graph should be like maybe a bit lower than like this. Yeah, okay. So let's move on to question number 9. Question number 9 here says that Jia Li conducted the following experiment. This is an experiment. There's the upper surface of the mirror placed here. This is basically a mirror. There's upper surface up here, lower surface here, and there's a tripod stand on top putting a beaker of water at 60 degrees Celsius. And you can know that this is a kind of a hot water. There's a warmer water vapor that will be going up. And here says that which of the following will most likely result in an increase in amount of water droplet formed on the mirror. So with that, you should guess that this is actually condensation. The warmer water vapor came in contact to the lower surface mirror, the cooler surface of the lower surface mirror. It loses heat, condenses, and form water droplets. And what happened is now they want you to increase in the amount of water. So in order for you to increase the amount of water, what you are supposed to do is to make this, either you make this water to become hotter, or you make this mirror to be cooler. Okay, you get the idea, right? Either this hotter, either this cooler. So in this case, let's look at one. One, remove the tripod stand. Seems like it doesn't work well. Add ice to the beaker of water. Now, I told you it need to be hotter, right? So you add ice doesn't help. Place a cold towel on the upper surface of a mirror. Means that you put a cold towel here. Does it help? Yes, right, because it makes it cooler, right? The whole thing will be cooler. Then when it's cooler, more water will form. So option number 3. Okay, so this is actually off, okay, not all. Sorry for my mistake. And let's move on to question number 10. Sharik fill identical containers QRS with 50 ml of water each and cover them with different lids as shown. He left the containers at a science lab and measured the volume of water left in each container after 3 hours. So with this, you can see that they are measuring the amount or volume of water left, but you're just leaving there and wait for the water and see there's water left or not. So you should able actually guess which process is being tested here. Let's go back to our booklet 2 and check. Is it freezing? No, it should go 0 degrees Celsius. Is it melting? No, there's no ice. Condensation? No, there's nothing like about hot and cold. How about boiling? Is it boiling? No, boiling, it should have a heat source that heat until 100 degrees Celsius. So the best possible probably will be at evaporation. And since you are testing whether the amount of water left is it a lot of more or not a lot, like lesser, then you should actually think of these 4 factors affecting rate of evaporation. So there's temperature, humidity, wind, and exposed surface area. So from here, what do you think it should be? I mean, if you observe clearly, evaporation takes place at the surface of the water. But there are some that is a bit covered, some is open but a bit middle in between Q and R. So that actually gives you an idea. This is actually the exposed surface area idea, the factor that affecting the rate of evaporation. So let's look at here. The greater the surface area of the water, the greater the rate of evaporation. So let's look at here. This one have the greater exposed surface area. So the rate of evaporation will be higher or lower? It will be highest. Then this one will be the first one, okay? Then this one will be the one. It will be the second one because it actually have a slightly smaller gap. But this one will be the third one, the last one, because it have the smallest. So evaporation can't take place that well because it's too small here. With that, you know what? I have Q, I have R, I have S. Okay, let me draw the graph. If it is the highest rate, means that there are less water or more water. I mean, for sure there will be less water, right? Because it evaporates faster. It gains heat, it evaporates faster. So this one should have lesser water. S, the second, should be have slightly more than R. And Q with the most. And with that in your mind, can you just take a look and think which one actually shows what you actually draw up here? You notice it's actually option number 4. Correct? Again, so you must know the concept here, the 4 factors affecting the rate of evaporation. Okay, if you don't know this concept, you can't understand and do this question. Next one, 11. A beaker of ice cube was left on the table to melt. Again, ice cube left on table to melt. So after melting, the water reached room temperature. The water was then heated over a flame until it boiled. The flame graph was plotted to show the changes in temperature over the period of time. Now, based on the graph, which of the following statement is not correct? Means that it's false. Now, the first one, the room temperature was 28 degrees Celsius. Is it true? As you can see, ice trying to melt, it increase in temperature, then it maintain, it going up, it maintain. So 28 room temperature is actually fair enough, right? It's fair enough. So number 1 is correct. Number 2, all ice cube had melted after 5 minutes. Again, we know that the ice cube will remain the temperature at 0 degrees Celsius and the temperature only will increase when it's fully melted. So you can see they say have melted after 5 minutes, which is true. After 5 minutes, the temperature increases, means that it have already melted fully. So number 2 is correct. Number 3, heat from a flame was supplied at point B. Point B is maintaining the same. Does it supply? No. It's supposed to be at C, right? Because it slowly increases. So number 3 is false. Okay, so let's move on to question number 12. Question number 12 here says that 4 identical beakers WXYZ filled with the same amount of water were exposed to different conditions as shown in the table. Again, the water exposed to different conditions. Which of the following beakers will contain the least amount of water after 1 day? So again, with this topic, when you annotate, you should kind of identify that this is actually evaporation. And this is again about what? The 4 factors affecting the rate of evaporation. This one. So you should know, the greater the temperature, the greater the rate of evaporation. Okay? The greater the presence of wind, the greater the rate of evaporation. Okay? So now let's look back here. When it's cold but windy. Now again, temperature high and the wind speed is high, it will be faster evaporation, right? When it's cold, does it help? Not really that much. Windy? Yes, it's good. Cold and not windy? No, there'll be less rate, the lower rate of evaporation. How about sunny day? That's good. How about windy? Yes, strong. How about sunny? Yes. How about not windy? Maybe not that much. So you can see why. What happened to why is that it actually have good higher temperature, it have greater wind, That's why the rate of evaporation will also be higher. And when the rate of evaporation is higher, the amount of water is lower. Why? Because it evaporates already. So which one is the one with least amount of water? Number 3, option number 3. Okay, so let's move on to look at section B, the open-ended question. Now, here says that Mark wanted to find out how the number of plastic bags used to wrap ice cubes would have affect the time taken for ice cube to change completely into water. Now, when you see the word to find out how the number of plastic bags used to this whole sentence would actually be the aim. Let me try here the word aim of the experiment. Now, because usually aim always start with this word to find out affect what. To find out what affect what. Okay? So he prepared 3 setups, ABC as shown below, with the ice cube of the same size. Now, the ice cube is in the same size. Now, you can see setup A, you have 1 plastic. B, you have 2 plastic bags. C, you have 3 plastic bags. Now, the time taken for all ice cube to change into water completely is shown in the table below. So you can see A is given 30, B is 62, C is 54. Now, let's look at A. Name the process. Again, the way they ask you name the process, you are just supposed to tell me the name of the process. Ice cube become water. That is what? Ice become water. That is melting. Please just write the word melting is good enough. Don't need to tell me the process that caused the ice cube to change into water is melting. Don't need. Melting. Straight to the point. Because they ask you just name. But when they ask you to explain, example, the second question, explain, then you must explain it clearly. And when I ask you to explain, you are supposed to explain in a more scientific way. Again, I actually repeat this word scientific many times in some of your tests. I write that scientifically because you just explain it in a like normal way, which is actually not scientific. Now, and a lot of you misunderstood this question. Let me just explain this. Explain how using ice cube of the same size, ice cube of the same size, ensure a fair test. Now, you need to understand one thing first. Fair test means that I want to have everything to be the same. Only the things I want to check whether it affect that thing can be different. The rest must be the same. Okay? And usually they ask you how to ensure a fair test. You say, oh, by using the same size of the ice cube. But now this question already say ice cube of the same size. But now they are questioning how using this ice cube with the same size help to ensure there's a fair test. They already give you the answer, but now they want you to explain how. Okay, now and many times you can answer using this way of writing. Okay, so it's very important for you to actually know how to answer this kind of question. Okay, how? By using the ice cube of the same size, it actually ensure that the result is only affected by the number of plastic bag, but not the size of the ice cube. Because you want to be fair, ma. If I give you one big ice, one small ice, I wrap it doesn't make sense, right? Okay. So let me just explain in a more scientific way. So you can say so that the difference um in the time taken for ice cubes to melt is only due to the number of plastic bags. Now again, let me just quickly bring you up a bit. Again, I told you, right, this is the aim of the experiment. And the aim always mention this. The number of plastic bag used to wrap ice cube, this is something we call as a change variable. Something you want to test, right? That's why you put different. Can you see? One plastic bag, two plastic bag, three plastic bag. And effect, this is the result. This is the result. And why I want to use the same size? Because I want to ensure that the result is only affected by the change variable. That's why I say the difference in time is only due to the number of plastic bag, wrap around the ice cubes. Okay? So again, this word is only due to, it's very important because um yeah, it's very important. Okay? So let's look at the C. Do you agree with the result? Do you agree with the result shown in the table above? Explain your answer. Again, explain your answer. Now, let's look at here. Okay, firstly, you should understand the concept first. When I have one plastic wrap, two plastic and three plastic wrap, actually, the main idea you're supposed to understand is when there's more plastic wrap, it actually is, it takes more time to melt. Again, I repeat, when there's more plastic bag, it actually takes more time to wrap, more time to melt. Why? Because there's more plastic being wrap, and there's many air inside. Can you see air? Air inside, trapped inside, right? And that air is actually a poor conductor of heat. Now, this is what you learn in P4, poor conductor of heat. That's why heat cannot really go inside. That's why, because ice need heat to melt. But again, because heat cannot go inside that easily, that's why the ice takes more time to melt. Okay, again, whereas this heat can go in very easily because it's only one blocking. Okay, and this is what you are supposed to write. Again, so when you compare, A have 30, okay, B have 62, but C have 54. Not possible, right? Because C should have more than B. Again, because there's more plastic bag, more air is trapped in between the plastic bag, and as air is a poor conductor of heat, heat cannot transfer in easily. Okay, so how you're gonna explain this? Do you agree? You are supposed to be no. Why no? Because the time taken for ice in C to melt should be longer than who? Longer than who? Than B. Why? Because C has more plastic bag. C has more plastic bag, which traps air, and air is a poor conductor of heat. Therefore, heat transfer from surrounding to ice is slower. Okay, you can pause and you can write. Now, that is basically the idea. Now, but I just want to quickly mention this because I noticed a lot of you have a misconception. Now, a lot of you say is this, when there's more plastic cover, there'll be more heat. Now, again, let me just remind this again, a lot of misconception here. Misconception. Misconception means that you misunderstood, you understand it wrongly. Is that you thought that when there's more plastic, there's more heat because you feel like, oh, it will be very hot. Okay, you cover it, will be more heat. But that's wrong. Why? Yes, if you cover yourself in many like plastic or many blanket, right, you feel hot. Why? Because you yourself generate the heat. But ice don't generate heat themselves. Okay, so you cannot say that, oh, there's more plastic, there's more heat. Okay, because ice don't generate heat themselves, but human, yes, we does. Okay, we do. Okay, and you need to understand that that's why we have like this like example of thermal flux that you put ice inside, it will melt longer. Okay, because heat cannot go inside. Okay, heat cannot go inside. Now, there are some of you also explain in such a way that you say coolness is trapped inside. I mean, um, because you say like cool will not lose, right? Okay. I mean, it's okay, like kind of you understand in this way, but when we explain, we always explain from the side of the heat. Okay, instead of the coolness that you mentioned, we always explain heat. Heat cannot go inside, rather than coldness cannot go outside. You get what I mean? Okay, explain in the from the perspective of heat. Okay, so that's all for this part, and let's move on to question number 14. Question number 14, what is evaporation? This is a very, very simple question, but it's given 2 marks because you need to explain it clearly and nicely. Yeah, a lot of you kind of okay, you mentioned this, you say that liquid to gas. I mean, okay, but you must explain it in a nice way, okay? So what is evaporation? The process whereby water turns from a liquid to a gaseous state. Now, if you stop here, is it true? You stop here, it seems like correct, right? Yeah, liquid become gas. But the problem here is boiling also happen in the same way. It's also from liquid to gas. That's why you must even explain more with the word without boiling. Again, I repeat, you must add the word without boiling because or else this will be exactly like kind of similar with boiling. Okay, so let's move on to understand the next question. The diagram below shows a car with its glass window fogged up. Now, the temperature outside of the surrounding air, means the outside of the car, is 17 degrees Celsius. Let me just quickly circle this. So it's cooler. Let's write the word cooler. But temperature in the car is 25 degrees Celsius. So it's actually hotter. Now, again, you must understand that when there's cold, when there's hot situation in kind of like this, and there's the word fog up here, you must able to identify the concept here is supposed to be condensation. Again, I repeat, condensation. So let me bring you back to the notes here. This is the notes for condensation. Okay, now again, condensation. And when it comes to condensation, something like this involved. Again, something like this involved. Okay, let's look back to this. You know that it's fog up, but the problem here is fog up inside or outside. Means that it become like the glass window become blur, right, because of fog up. But inside or outside? There's something that we always need to question ourselves, inside or outside. And you must understand this. The fog up part is always happen in the hotter part. Again, I repeat, the fog up is always happen in the hotter side. Hotter side. So means that temperature inside is hotter, right? That's why the warmer water vapor inside the car came in contact with the cooler surface of the window, loses heat and condense and form tiny water droplets. That's why inside becomes fog up. Okay, inside of the car, not outside. But if I change the question to become outside is very hot, inside is very cold, then the fog will happen outside. Okay, so let me repeat again. When the fog up will always happen in the temperature in the side of the temperature where it's hotter. Okay. Now and here say what? Here say Mary drew a star. You need to understand that how she actually drew the star. Because some of you say, oh, use crayons, use color pencil, use marker pen. No, 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 no. is actually already fogged up, means that there's tiny water droplets, but this person used hand to go and draw the star. Okay? Means that when the question asks, Mary drew a star on one of the window of the car as shown. Was Mary draw in the car or outside the car? Means that, yeah, actually the question is asking the fog up happened inside of the glass window or outside of the glass window. And as I mentioned, right, because inside is hotter, that's why the tiny water droplet is formed inside. And because it's inside, that's why he can use her hand to draw the star. Okay? A lot of you write marker pen, all this thing. No, 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 no. It's not about marker pen. Okay? So the answer is in the car. Okay? But now you are supposed to explain, right? And you explain the same thing as I've just mentioned. So the first thing you should explain is the temperature. The temperature inside is warmer than outside. So let's explain this. The temperature of the air inside is warmer than outside. And because of that again, so the warmer water vapor came into contact. Okay, you must mention inside the car, or else it's a bit confusing. Inside the car came into contact with the cooler surface. Let me use the word cooler inner surface, okay, because inside that, right? Cooler inner surface face of the window. Again, lose heat and condenses to form tiny water droplets. Okay, so again, you should understand the concept again. When it's hotter inside, colder outside, it will fog up inside. If it's hotter outside, cooler inside, it will fog up outside. Okay? And again, because on that side that is fog up, that's why you can draw using your hand. Now, let's move on and look at question D. Question D here says the car was then parked indoors with a surrounding temperature of 30 degrees Celsius. Will the star remain, or it will disappear? Explain why. Again, when you ask you to explain, you must explain clearly with scientific terms. Okay? Now, the first thing you should understand is again, inside is 25, right? Now, outside is 30. 25, 30. So with that in mind, you know that the difference in temperature is not that big. When there's not that big, actually what happened is it is hard to fork out, okay? Because yeah, okay, because the difference in temperature is very near to each other. And they ask you, will it remain or disappear? Some of you they say yes, no, 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 no. You must ask remain or disappear. But in this case, it will disappear. It will disappear. Why? Firstly, you should understand that because the temperature is too near to each other already, so there's no a cooler surface to condense because it's 25 and 30 is actually kind of a bit hot already. And the second thing is don't forget there's another elements inside called evaporation, right? Okay. So you write here it will disappear. Why? First thing you should explain there is no cooler surface for condensation to occur. Okay, so if you want to explain even further, you can actually explain that. So the water droplets, again, the tiny water droplets will what? Will gain heat because it's kind of hot already, like for 30, 25 degrees Celsius. Gain heat from where? From the warmer air outside, outside, and evaporates. Okay? And because of that, the star disappear. And you understand like because I draw star outside, I mean the surrounding is water droplets. So the one I draw, it means disappear already, the water droplets. That's why evaporates, then the whole thing gone. Okay? So that is basically the whole question. It's kind of long, but yeah, that is basically the idea. Again, you must understand how this condensation works in this case, okay? No crayon pen, no marker pen is using hand, okay? So now let's move on to 15. Again, 15. Raja wanted to find out if temperature of surrounding air affects the rate of evaporation. Again, highlight the word, or I should say circle the word in this case, to find out if temperature of surrounding air affects the rate of evaporation. Again, when I told you just now, right, when you see the word to find out, what does it stand for? This is actually the aim of the experiment. To find out if temperature of surrounding air affects the rate of evaporation. So temperature of surrounding air is actually the change variable, something that I need to change to test the result. Change variable. But the rate of evaporation is the result that I want to see. And how can I see? By looking at the bin balance. That is the how I differentiate. So, but with that, you should actually think back your booklet too. This is evaporation, right? So look at your evaporation part. Do you see this four factors affecting the rate of evaporation? The greater the temperature of the surrounding, the greater the rate of evaporation. So this concept should be in your mind now, okay? The greater the temperature of surrounding, the greater the rate of evaporation. Okay, so this is higher, this is higher. So now let's continue to read the question. He wet two identical shirts with the same volume of water. He then placed two similar lamps at different distance from the shirt as shown. So you can see that the lamp actually take the role of affecting the temperature of the surrounding air, and the shirt takes the role of testing the rate of evaporation. So now A, what is the purpose, again, the purpose of lamps in the setup? Wow, some of you look at the word purpose, then you just write to find out if temperature. Yes, yes, yes. But they're asking only the lamp. What is the usefulness of the lamp? Again, I told you, right? It actually takes on the role in controlling the temperature. So you can say it is to increase increase the temperature of the surrounding. Again, you should actually understand that this is the word that you should always refer back. This is the part you should always refer back. The temperature, the rate of evaporation. These are the two things you must mention. Now, B, after 3 hours, the bin balance tilted downwards to X. So now, example, it will be like this. The shirt like this, the shirt like this. Example, okay? So X going down, Y going up. Means that X is actually more heavy. Why is it more heavy? Because there is more water. And of course, here is less water. When there's more water, does it tells you the rate of evaporation is higher or lower? It tells you the rate of evaporation is lower rate of evaporation. And we actually learned that, right? This is higher lah, rate of evaporation. I mean, and we know why, right? Because we know that the temperature is will be actually lower temperature. Why lower? Because it's further, can see. This is nearer. That's why it's more hot. It gains more heat. It evaporates faster. X is further. That's why the rate of evaporation, that's why the temperature is lower. The rate of evaporation is lower. Then there's still more water inside. So, explain why. So you can just, again, look at this. Look at this. This idea that I've just explained to you. Okay? So again, why lower temperature? Because the distance of the lamp is further. That's why cause lower temperature, cause less rate of evaporation. That's why more water, that's why more heavy. Okay, so you're explaining this way. Okay, so the first, the lamp is further from the from the shirt X from shirt X lah. Let me just use the word X lah, from X, and because it's further, let me go back to here, because it's further, that's why the temperature of the surrounding is what? Lower. And the temperature of the surrounding is lower. And when there is temperature is lower, what happened? The rate of evaporation is slower. Why? Because it gains less heat. Then X gain less heat, and the rate of evaporation is slower. Then when there's less, then it will be more water, more heavier. So there is still more water on the shirt, thus more mass. That's why it's tilted. That's why. Yeah. So I know it's 1 mark, but why it's so long? But you need to explain it step by step and clearly. Okay. And some of you just explain because it's more heavy. We know it's more heavy, but you must explain the theory behind that. Okay. That's why the word explain is very important. You must explain it clearly with scientific terms inside. Okay. Now let's look at this. After 5 hours, the beam returned to the original position, and I ask you to explain why. Correct? Some of you, oh, dry up already. Which is true. It returned back to original position means that they have the same, right? Which is good. They dry up already, I know. But you must explain more. Dry out means what? Okay? So you can say X has also dry up. Yes, I know. And now, dry out means what? And now, both should has the have the same mass. Means that now their mass is the same. That's why it go back to the original position. So you just mentioned dry up. Yeah, but how does it affect the beam balance? Dry out. That's why the mass are the same. That's why it return back to the original position. Again, you must explain clearly when there's a word explain. Now, I actually asked you to write down this one, right? Explain. So you must explain clearly. Now, let's go back to go to next question. Question 16. If you are tired, you can pause the video and rest for a while, okay? So, question 16. Shi Chen carried out an experiment using setup A and B as shown below. So, this is an experiment. Fan in setup A was switched on during the experiment, but fan in setup B was not. Now, fan switch on, fan does not switch on. And you notice that in setup A and B, there is a water. Can you see the word water here? Fan, water. What actually come into your mind? You should think back booklet 2, look at this, and water cycle booklet, right? And there's a fan, and fan gives you what? The presence of wind. So you should immediately think of this. Now, can you see this? This is the what you should thought of now. And with this, what does it tells you? The greater the presence of wind, the greater the rate of evaporation. So let's go back to test number 2A first. After 3 hours, she recorded the amount of water left in each beaker. Which setup A or B would have less water be left in the beaker? Now again, I know the greater the presence of wind, the greater the rate of evaporation. And when there's a greater rate of evaporation, there will be less water in it. So less water means that there's a presence of wind. So which setup? Setup number A. Again, you must understand this. If you don't understand this concept, everything is gone because you don't know how to answer. Now, again, remember that you are supposed to explain your answer. And how you explain? You must explain scientifically. You must use the scientific words. Some of you, right? Okay, some of you didn't use any word about wind. But wind, this word is very important here because you cannot just say wind, the fan on, the fan on, then yeah. Some of you just write the fan is on, that's why less water. But how? You must explain, okay? First, setup A, and I know setup A, the fan is on. And when the fan is on, what happened? There is the wind, the presence of wind. The greater wind movement is present. Yes, because the fan is on, there is wind. And what happened? The rate of evaporation is higher. The rate of evaporation, okay, let me just explain, of water is higher. So again, it's the same thing here. Presence of wind higher, rate of evaporation higher, less water. Okay. So now let's look at B. B here says state the aim of Sichen's experiment. Sichen's experiment. Again, I know is what? It's all come back to this thing. The wind, the evaporation. So how do you write aim? Again, I told you already just now for many times. It's always to find out if change variable affect the result. And what is a change variable that I have here? What's something different here? The fan, right? But you cannot say right the fan, the on and off, whether the fan is switched on or switched off. Now, the key word here is the presence of wind. Affect the result is what? The rate of evaporation. So how you should supposed to write? You're supposed to write in this way. To find out if the presence or you can say the amount of wind affect the rate of evaporation. And that is a good aim that you are supposed to write. Okay. Now again, explain scientifically. So some of you say to find out if the fan is on or off, does it affect the water? Yeah, it's not scientific enough lah because you must have these words come in your mind. Presence of wind, evaporation, yeah, all these things. Okay. Now the last part here says, what was the purpose of the container in the experiment? So you can see that there's a container here is cover, but it seems like for what? Okay, now you first understand that because we are now testing about wind, right? So one have wind, one don't have wind. If I don't have the cover, then maybe B side they have a bit more wind blowing. Then it's not accurate already, right? Okay. So the first thing you can think of is to actually ensure a fair test. Ensure a fair test. Okay. But of course, you can't really just say ensure a fair test, right? You must actually explain a bit more. Why we need to have this container? Okay. The first thing is you should say that it reduce the wind in surrounding from entering the setup Why? Because if B I don't want any wind, right? So if there's wind coming in, then it's not accurate anymore. So that again, the result of the experiment is only due to the presence of wind generated by the fan. So if you notice, okay, you can pause this video to write down, but I just want to mention this. If you can mention, if you see this right, because I know the container is to ensure a fair test. And whenever I mention that the fair test, this word, there's always a word coming. Is only due to. Okay, you see, only due to. If you still remember, in our previous question, in question number 13, B, can you see the word fair test? And when there's a word fair test, is always have this word is only due to. And what I always write, the result is only due to the change variable. So you can see, if I go back to this question, the result, what is the result? The result is basically the water, right? So I can see the result of the experiment is only due to the presence of wind, which is what? Which is my change variable. So it's something very interesting to know, right? Okay. When it's come to fair test, you will use the word is only due to da 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 da. Okay. So I think that's all for our test discussion. So I've already discussed many everything, and I actually talks a lot because I just want to ensure that you actually understand this test maybe better, because there are many of you that seems like kind of forget what you have actually learned in our tests, in our normal lessons. Okay, so again, I hope that you can really go through this video well, and please don't forget to do correction. Make sure you understand every single things here, and you can pass this test and let your parents or guardians to sign. Okay, and this. So I believe that's all for this class. Thank you. See you. Bye bye.